So today we are going to proceed to look at uniform distribution. So meanwhile, we have done Poisson distribution. I think also we have done other distributions in the previous classes. We did normal distribution, if you remember. Then we introduced the concept of seaborn. We have been using it to plot our chart. So today, let's move to uniform distribution and let's look at what it is. Well, in the context of NumPy, that's what we are looking at everything. The context of Python. Now, when we say uniform distribution, we're talking about we want to list a certain a kind of collections like a distribution that is uniform. That means they have equal opportunity of occurrence. Like in an experiment, you define a range, like you define the upper bound, lower bound, like the range. You want several numbers or data that will appear within that range to have equal probability of displaying. Do you understand? So that is what uniform distribution is. So all the elements, or I can say, okay, let me just make it a comment. All the elements or data within a certain range, which is, let's say, that means you have a lower fixed value, lower boundary now, or we call it lower bound, and then we have upper bound. Sorry, upper bound. So that is upper fixed boundary. Okay, so so all the elements within this range have equal oh, let me write it like this here, equal probability of occurrence, yeah, in an experiment. So in an experiment, okay. So let me also make it so enlarge it a little bit. So okay, this is it. So this is what we are talking about. So all the elements or data within a certain range or part, which implies lower bound and upper bound, so they have equal probability of occurrence. So now we're going to give a size of distribution. What is the size of distribution? So what we're going to look at, number one. Okay, let me just first of all, from what you have written now, you have the lower bound or lower boundary, value, lower bound value. And number two, you have the upper bound value. Then number three, you have the size. Number three, I can say it. Okay, size of the distribution. Okay, so the size of the distribution. So that is it. So we're going to list all the elements within there. So distribution. So like that is it. Now let me just run it. Let me just come to the next line. So the next line. So we're going to look at how it plays out. The first thing, let's import. Let's from NumPy now. Import what? What are we importing? We are importing random. Take note. We have been using random for a while now. Then what else again? Seaborn and Matplotlib. So import Matplotlib dot pyplot now, right? Pyplot as plt from, then import seaborn as sns, right? Yeah, so these are the three I think that we need. We want to be able to generate the values, and then after that we can plot it. So that's what we want to do. So the next line of action is what? So let's look at it now. The next line of action, let me just implement those ones. Okay, so the next line of action is to generate it. So let's come to random now. Random dot what? So we are going to look at a lot of things. We have done binomial, we have done a whole lot of things. You can see the various distributions here. That is values with like that. Poisson is there. Then so the one we are looking at now is uniform. So we just go to uniform here. Just put uniform. Then we can now list the boundaries, or lower boundary first. So I can say, okay, the lower boundary is between 0, the upper boundary is 1.0 or 1. Then I want to generate 10 values within the experiment. You understand? Or within the distribution, 10 values. So having done stuff like this, so I will save it in a variable called let me just save it in a variable called x. So if I run this now, or I print x, you see, so print x, what do you have? rating of x. So you're going to see, you see we have about 10 values inside the distribution now. 10 values. So we have specified a fixed range. It should not go above 1 and it should not go below 0. So that's what we have. So we're going to plot this graph. That is the next line of action now. Let me just put it. Plotting the graph. Okay. So plotting the graph right now. What do we have plotting the graph? So how do we plot the graph? So we're going to use cbond sns dot what. So we're going to say this plot. This. Let me just suggestion. Sorry, you see it. This plot, not dist. So this plot. I mean, you can easily make error there. This plot. Okay. So from this plot now, we can now put the x value there. And if we have it like this, we might not be able to get something reasonable. So let me just put plt first, plt.show. Okay, so if you run it and see, so you see that it's going to show you something that's not smooth. A curve, I mean, not really a curve now, a kind of bars that are not. That's not what we are looking at. Something like a curve, like curve ahead. So that's why we're not going to just leave it like this. So what we just did to add the kind of chart, which we just write KDE. KDE means kernel distribution density estimation. I mean kernel or kernel, if you want to check it, kernel density estimation. So KDE. So I'll put it like this. So I have it like this now. So I want it the kind of chart to be KDE. Okay. So if I run it again, let's see what we have here. So you can see the curve now. So this is uniform distribution. So you can also specify on your own, your practice, you can specify the boundary to be 1 and the upper boundary to be 5, lower boundary to be 1. So any way you want to specify it, but we are stopping within this range 0 to 1. So you can see that there are 10 values here, and then like that, 10 values, and then those 10 values, they have equal chances in any given experiment. They have equal chances of being picked. Like no one has higher chances more than the other one. So that's what we mean by equal probability or equiprobable. Okay, so you can put 100. Let's check 100 and see. 100, I think our curve should be smoother possibly also. So you can see now, so it has 100 values. Let's run the chart and see what we get from the chart. So you can see the chart now. So you can practice to do and see what it gives you. How do you get whatever you need to get? So this uniform distribution. So if you have any question, please you can put that in comment section, and just go through it and just look at it. Another assignment I'll give you is that, what do you think is the difference between uniform distribution and normal distribution? So just your own, just go through it. Thank you very much, and do have a nice day. I look forward to seeing you in the next class. Thank you.